Hey everybody, this is Mr. Beckstrom, and today I want to take a look at an example from section 7b. It says determine the following probability of meeting at least one left-handed person in 8 random encounters on campus when the incident rate is 12%. 12 in 100 people are left-handed. All right, so how would we go about figuring this one out? Well, we know that if we just met a single person, that the probability would be 12 out of 100 that that person is left-handed. But how can we kind of figure this out? And so I want to do this a little bit differently, just to kind of show you what we're doing here. So if I were to set up an x and a probability of x, probability distribution table. That's what it is. And I were to say, what are all the possibilities for X? There's 8 random people, so I could meet none of them that are left-handed. I can meet one that's left-handed. 2 of those people could be left-handed. 3 of them could be left-handed. 4, 5, 6, 7, and 8. So now you don't need to know how to do a probability distribution table, but I kind of want to, I think it would be really useful to kind of use this to understand how we're actually solving this question. So the P of X shows the probability of each one of these. And the question says, what's the probability of meeting at least one left-handed person? So what they're doing is they want us to take what's the probability of meeting 1, 2, 3, and adding all of those up, everything except for 0. So they want us to take 1 through 8 because at least 1 means it could be 1 or more. So they want us to take all of these 1 through 8 and add them up and add up those and add up the probability of X. And this is actually a binomial probability distribution table. So we could do that. We could actually do it in our calculator. We could do it by hand, although it would be pretty arduous. But we don't really have to do any of this. I just kind of want to show you what we're going to do. So remember that when we're talking about all the different probabilities, all of these have to add up to 1, right? So, if this probability is a 0.22 and this probability is a 0.16, like a 16% chance of happening, all 9, because they're 0 through 8, all 9 of these probabilities all have to add up to 1, because 1 means that's 100% of the time one of these are going to happen, right? So they all have to add up to 1. So what are they saying? Meeting at least one left-handed person. Well, what does this one here mean? What does this value here mean? This means meeting no one, right? Meeting no one left-handed, right? So the X means that 0 of the people that we met were left-handed. And notice that there's only one value here that we have to add up. And there's 8 values here that we have to add up. So the way that we're going to do this is we're going to kind of cheat the system a little bit. I'm going to say that the probability of all of these is really just equal to 1 minus the probability that no one is left-handed there. So in order to find this, the probability of nobody being left-handed, right? We're going to take, what's the probability that one person is not left-handed? Well, if one person is left-handed, it's a 12%. So if they're not left-handed, we know it has to add up to 100%. So that would be 100 minus 12, which is 88%. So this is going to be 0.88. This is the probability that no one is left-handed. We're using the multiplication property of probability, and we're going to raise that to the number of observations or trials that we have. And in this case, we're meeting 8 people, so this is raised to the 8th. So our solution here should be 1 minus the probability of 0, which is 0.88, raised to the 8th power. And putting this into our calculator here, 1 minus 0.88 raised to the 8th power is equal to 0.640. 0.640. And that would be our final value rounded to 3 decimal places, 0.640. All right, so it is pretty confusing. We really have to be able to set this up and understand what we're doing here. We can also put this into our calculator, and there's a binomial probability distribution function there. If anybody wants to know how to do that, just let me know, but it is a little bit beyond the scope of this course. All right, I hope everybody has a great rest of your week. All right, and thank you, everybody.